when you're setting up your systems and when you're setting up these different platforms for the data scientists or the machine learning scientists, and you're starting to think about what can we do to enable them more, how do you attack that problem? Today we've got something really special as we're building up to the Apply Meetup conference. I was able to talk to two of the speakers that we have, and we were diving into a little bit of what they're going to be talking about, a little bit of how they see things right now, what drives them, and what's going on with MLOps, with the current state of data engineering, software engineering around machine learning. So who did I talk to? I got to have a chat with Matt Delacour from Shopify. And we talked all about his different motives for working on Feast and what they are doing at Shopify when it comes to machine learning at scale, some of the use cases they have. And then after that, I was able to talk with none other than Karan Goel, who is currently at Stanford. He has a colorful background where he was coming out of Carnegie Mellon, and he's been in academia, but he is driven to looking at what is going on with the industry side of machine learning. We're going to talk about all that stuff and more coming right up. I would love to talk to you about the whole MLOps team or the whole machine learning inside of Shopify and what is going on there.
ML has been part of Shopify for the last couple of years. It just like we started with some managed services, and at some point we also wanted to just create a platform based on open source projects. So today we use like Feast, we use Ray, Airflow. So we really try to contribute back to the community in those projects. And it's funny because in all the open source projects we contribute to, like Feast or Airflow, we are one of the main, like one of the biggest user of those projects. So every time we are like just stretching the platform, and like we need to contribute to make things run at scale. But yeah, otherwise, like we have like a ton of projects going on in ML. Some being like the most famous one being like order risk. So every time there's an order, it's like what the probability of this order being a risk. This is something you can see in the admin. And this is a very complex ML model at the end. So we try to port it over to our like new ML platform, see how we can improve the model by maybe streaming pipelines at some point or generating streaming features. So those are all the things we are like looking forward in general at the platform.
So let's talk a bit about how you landed on Feast and what was it like? Did you have a feature store beforehand? Were you trying to create your own and then you went to Feast, or was it something organic that you just started playing around with and you realized this could be useful for us?
We did not have a feature store per se. So the team, like each team tried to reuse their own features, but it was pretty complicated. Also like hard to discover features that were available. So at some point we were interested in feature store in the concept and like having one. So we look at a couple of like project and even SaaS provider. And at the end, we wanted to compare even like what happened if we build it internally. And when we discovered Feast, the first time we reached out to them, it was like 0.9, and it was clearly not what we wanted. It was coming with like a heavy infrastructure, a ton of components we would have to manage. And therefore, like we had a chat with Willem on the team, and they were like, oh, wait, there's a new version coming in, 0.10, and basically it's a light SDK, plug and play. You can have your own provider, your own like offline store, online store. And we are like, this is exactly what we want. So even though we knew that like C 0.10 or the current version was like pretty new, we decided to give it a shot for the long term. We're like, we don't want to invest like 6 months or building it everything internally. We prefer to just like contribute it back to Fist and make it as we wish or as we want in the long term with the community, rather than just duplicating the effort and everything. So it was really like the chat we had with the team, and when we talk about the vision of what the long term we are looking for and what they are planning to build, we are like, I think it's a good match. So we can definitely give it a shot, and yeah, that's a long term bet. That was a long term bet. That was not a quick win on our side, definitely.
It's cool that you're contributing back. You're not just take. You're putting something back into these communities. I want to know what some big hurdles or challenges were when you started using some of these open source projects. Like you mentioned, we're contributing back so that they can run at scale. I imagine Shopify has a ginormous amount of scale that you're running at. And so, what were some things like, do you have any concrete things where something broke because it wasn't able to handle the scale that you were trying to push through it?
Yeah, so on the Fist side, it was mostly like, for example, historical retrieval was working, except when you were trying on billions of records, and it was just either BigQuery didn't want to process data, or something else was broken. On Airflow side, it's if I recall very quickly, it's one of my friends work on it, and it's if you start too many jobs in Airflow, at some point the Airflow scheduler will have some race condition, and therefore he just detected at the end he was running an experiment on like 50,000 scheduled jobs, and he just saw that 1.5% of the jobs were failing because of an issue. And so it's very small, but at the end, like our jobs were failing at the same rate. So we just made a contribution on the fix to the Airflow repo. I don't know exactly all the technical details. We just chat about it very quickly, but this kind of story. Same with Fist, basically.
What were some things that you noticed right away that made life easier for data scientists or different teams that are working on ML?
So what we like from the beginning is how the code was organized, and think about, like, for example, from the beginning, from day one, there's a CLI. So you can just go in your command line and say Fist apply or Fist materialize. And then after, like, very quickly, we are like, okay, we need our own provider. So we modify the code with them, like they modify the code so we could create our custom provider. So after that, it was really the flexibility of like, we have our own online store that is like something custom. How can I just plug and play my own things? So it's definitely like this flexibility that we really enjoy today. And the fact that it's just like solving all the business problems for us at the end, like down the road. So it's like there's an API to do historical retrieval. That it's going to be done and well done, and therefore we have less and less business logic to do. So yeah, no, it's definitely like a great, like, it's a very easy product to try and to just start with. The things I think we are missing, but it's like part of the RFC, we are like just building with William. It's like a couple of features that can be like, how we do on-demand transformation, or how can we have like a better feature discoverability. So either by plug and play with another service, or just by having a look to all the features very quickly and the relationship. So then it's how can we make it better?
And as far as the data scientists, are they using this, and have you gotten any feedback from them?
What they really like is the consistency between the offline store and the online store. The fact that you are going to define one pipeline to generate the features, and then you know that when you are going to do historical snapshot or historical retrieval from the offline store, or if you query directly the online store, you are going to have like consistent data. And that is something very appealing for data scientists. Another thing that some of them, it depends on the use case, really enjoy is like the point in time join, like going back in time. So it allows them to prevent what we call data leakage. And it just like, if you want to train your model 6 months ago, you want data as if we were 6 months ago. So it's really something also like they're like, oh yeah, before I had to do it manually, I had to create like a PySpark job and like do some maybe window function or group by and do it manually. And now it's like it comes for free kind of. So it's definitely very appealing on that side. So we had good feedback so far. And where data scientists are really exciting about it, it's really about discoverability. The fact that someone is going to create a feature, let's say average order value, and someone else is going to use it and just going to trust it, and it comes like the entire ecosystem around it, like online store, offline store, yada yada yada. So that's very appealing for them.
Yeah, and that's something that is huge, and I hear over and over again is the reusability or reproducibility, and uh, that is so important. I think it can't be understated how difficult it is when you have data involved and when you're dealing with different data products or machine learning stuff. It is not such an easy nut to crack. And so the more that you can do that, and it's really a fundamental piece of MLOps, in my opinion, especially when it comes to reproducibility and reusability. You don't want to be reinventing the wheel every time you're doing something and then taking up more and more time from these data scientists or the machine learning engineers that are, they don't necessarily need to be doing that repetitive task. So as you're looking at when when you're setting up your systems and when you're setting up these different platforms for the data scientists or the machine learning scientists, and you're starting to think about what can we do to enable them more, how do you attack that problem?
Yeah, I think in the current workflow now, the main the main pain point from them for them will be about generating the feature, like how we create the features, either streaming or batch, um, that contains the value historically, and then you can give that to this. So I think it's really that part that it takes the most time to them right now. Um, and yeah, creating good qualitative feature is an important part. Um, uh, and at the end, it's creating ML model is doing some exploration, and it's trying out things on like notebooks and trying features, and then I think that part is pretty much understood and well done. Like there's a good ecosystem around like trying out things, experimenting. But once you know the ML you want to build and the features you need to create, creating the features, sometimes you just end up having like some scaling issues that's, so it's definitely like an area where I think the entire community can focus on at some point. Yeah.
And do you ever go about, I was just talking to a friend before we jumped on this call about how to quantify these different projects. And when you want to do something, you want to actually build something because you know there's a problem there. Say maybe it's that this piece could be automated, and then that creates less mistakes because it's automated and you don't have the simple bugs being introduced. But how do you quantify that? Like, how do you make the case for creating that and going about putting the time and energy and resources into it?
That's a great question. I mean, we often do like OKR at Shopify, objective key results. Um, and like when people comes to me and say we need to do that, and the objective is to reduce the time to complete tasks, I feel it's really hard to measure like time completion of anything because that's so many factors. So to be fair, I don't have a good answer for you. I'm like, I wish I knew how we could really like estimate that. I think time completion would be ideal, but it's very very hard. um so yeah.
Yeah, because I was just talking about it with my friend, and he was saying, "Yeah, how can we really quantify it? You know that it takes time, and you know that it takes resources, and it takes maybe engineering effort, but how can you say, okay, an engineer is getting paid this much and it's going to take X amount of man hours from these engineers, but that is just a guess, right? So even if you did guess that correctly or in the ballpark, it still could be totally off if something gets introduced while you're working on it and then it blows up and takes much longer.
No, definitely. And I feel in some companies, um, we tend to focus too much on the short-term results. But like, sometimes you can like, you're going to invest some time and spend a bit too much time on building some foundations. But if those foundations enable, others going faster or automating a couple of things, I think it's definitely worth it at the end. So I think, yeah, the trade-off also between like short-term objective of like, we need to ship something valuable, let's say for our merchants, and long-term that is like, how can I create something that's going to take more time, like a feature for Feast. It might take more time because it's generic, so I need to think more about it. But at the end, everyone else is going to be able to use it, right?
So talk to me a little bit about the design principles or the experience of working with Feast as a community and then working inside of Shopify and how those differ.
Like the same analogy where you say alone you go faster, but together you go further. And it's kind of like similar with the open source project here. Like when we have an idea, we're going to talk to Fizz, and then we're going to open sometimes an RFC or GitHub issue. And then all the people is going to comment, and we need to wait for them to comment. And then there will be some back and forth. So sometimes you can feel that, oh God, I'm going to take much more time by using Fizz instead of like doing it internally. But at the end, you are going to have like much more brain focused on the same problem, trying to tackle the same issues, and therefore you are going to end up with, I feel like, better solutions for the long term, like better architectured or like with less edge cases, and try to not cut the corners on everything to go faster. So yeah, I feel it's a good trade-off so far. What's important in this case, it's how we can align our roadmap to the Feast roadmap, like if there are things missing, so that we are sure that either we can adapt or we can make the roadmap on Feast adapt. But the point being, like, we are not blocked for 6 months because we really need something. So I think at the end it's more like how can we have this roadmap, have like some long-term vision of what we want to build for our users, and get that match with the open source project.
Excellent, dude. Well, it's been great talking to you. I thank you for these 15, 20 minutes where we chatted up all things Feast and how Shopify is using it. And I look forward to hearing about your presentation in the upcoming Apply meetup. What can we expect for that presentation?
What we are going to get is how much it's cool to contribute to this project so that you can enable things for everyone. So for our case, this was how we can make Feast scale to billions of records, to process billions of records. But at the same time, like, I'm sure other people can contribute to other parts of the system and enable very cool stuff to the entire community. So really looking forward to show you that, and I hope I will convince you in like contributing to the open source project at the end. That's my goal.
Excellent. That's a very noble goal. Well, I appreciate it, Matt.
Cool. Thanks, Demetrios.
So that was the conversation with Matt. Now let's get into what I spoke to Karan about. Before we do that, I encourage you, if you are not already registered for the Apply Meetup Conference, do that right now. You've got the link in the description. It is going to be a blast. I'll be hosting it, so you know it's going to be fun. Now, last but not least, if you are liking this, please let us know. Show us some love. That's all I ask for. All right. So the Apply Conference, totally free, totally available for you. It is all the details, everything you need to know about it in the description below. Jump in. And now let's talk with Karan. Well, Karan, it looks like we're both in Hawaii today. And I really appreciate you talking with me about all this stuff. We should probably start from the beginning and just get a bit of background on who you are and what you do.
So I am a third-year computer science PhD student at Stanford. I work with Chris Ray, and I'm interested in like machine learning and building systems to robustly and kind of reliably build these systems and deploy them. And so, interested in tooling and just kind of understanding what the main kind of problems and bottlenecks are for making that happen. And obviously, I do a bunch of stuff on the academic side, but a lot of these issues crop up in industry because that's where a lot of the people are actually doing the work to deploy models and build systems. So that's why I'm pretty always kind of interested in kind of what different startups are doing, large companies, and kind of talking to people in industry about problems and so on. So that's kind of my background right now. And before this, I was kind of took a pretty traditional academic route. So I did engineering in undergrad, and then did a master's in machine learning at Carnegie Mellon, and then I came to do my PhD at Stanford. So I kind of wandered my way around different areas and some fields of machine learning to get to this point.
So, academic life of machine learning and industry life of machine learning generally are worlds apart, if not universes apart. How do you merge the two?
Yeah, I think it is pretty different. But I think like a lot of academic work in machine learning, especially around systems, it almost certainly has to be in collaboration and at least very close to what folks in industry are doing, because for taking a concrete example, right, like model monitoring and like these types of problems are pretty important, and there's a lot of technical work that still needs to be done there. But in academia, people don't actually deploy machine learning models typically. So model monitoring is a made-up problem in academia. So you really need to talk to people in industry and understand what is important in these problems to actually make progress for that's meaningful, right? And that actually will get deployed, get used at some point. So that's where I think there's a kind of a boundary that's being bridged a little bit in a lot of these areas because of the need that arises in industry for the solutions that are being developed on the academic side.
When you look at these two different worlds of academia and industry, they don't necessarily share data. Like industry doesn't share data with academia, and academia doesn't necessarily share everything it's got with industry, or it works on problems that are not related to industry at all.
Mm-hmm.
Do you feel like you're trying to change that a bit? How would you look at this whole problem?
Yeah, that's definitely pretty accurate, I would say, in my experience, that obviously like it's hard to get access to data that's locked into companies that are building solutions for customers and so on. So that definitely doesn't happen super organically, but it's always possible to set up collaborations or to build kind of trust with like companies to work on these problems. So from my own experience, I part-timed at Salesforce research, and that's where we built like the Robustness Gym project. That's how it got built out. We kind of started it as a collaboration, and then did building in open source, and we're still building that project out in our lab, and Salesforce is also doing that work. So that work is very ongoing. But it started in that kind of collaborative place. And another example, I just started at part-time at Snorkel AI last week, and again, it's kind of this interesting position where like they're also interested in using some of the stuff that we're building in our lab and kind of the research that we're doing. So it's kind of a tech transfer type situation where we're kind of building these technical ideas, and we can take those and apply those in these companies. And in exchange for that, I get to see, how they're building these systems, what kind of, problems they're running into, and so on. So it's kind of a great way to get more visibility into that process. So I think like these types of collaborations and things are definitely one big way that this happens. But there's definitely not like a one size fits all solution. Like I think different labs in academia kind of figure out how to get more access to that information in industry. And it's typically, through collaborations. A lot of these labs also just have their own startups. Zorko is spun out of our lab as well. So, there's kind of close relationships that we have with a lot of these folks that we can tap into.
What is your end game? What are you looking to accomplish here?
Yeah, I think personally, I'm really motivated by this kind of future of machine learning where we build these machine learning systems very interactively. So like we're able to build systems that have natural interfaces for humans to quickly understand what a model is doing, quickly repair it, and quickly iterate to a great system that can work well in practice. So that's kind of the end game for me. And I think like the current practice is not necessarily that focused on this notion of interactivity. I think like one thing that I'm very interested in trying to recognize over the next few years is like the fact that it's a human in the loop system, right? Like there's a human operator versus an engineer or a data scientist or a business person that's gonna, or a doctor, different kind of personas that are going to run and interact with the system. And so we need to kind of think about how to make the system as automated as possible, but also what are the right ways that the humans will interact with this kind of pretty powerful automated set of models and systems and tools, like even maybe things like GPT-3 and so on. So that's where this boundary between like human and system, that's what I'm pretty interested in. And a lot of these challenges of how to make systems that are monitored better or like easy to maintain, all of those are part of that boundary.
Oh, I love that. So basically, you're saying we're going to have humans be involved in this. So let's look closely at how they're going to be involved in this. Where are they touching the system and where does the system do its own thing?
Exactly. That's exactly right. Like there's going to be very natural touch points. And especially for machine learning systems, which are going to be the main vessel by which you actually deploy things that are used in practice, right? They're going to have the biggest impact because they're going to be used by companies, by hospitals, by nonprofits for various different things. And so for those things, you need to figure out how do humans work with those systems? How do they manage them? How do they improve them? How do they program them? So that is really I think the most fascinating thing as far as machine learning as a kind of engineering discipline. And
where do you feel there needs to be a bit of an uptake in how things are being done when it comes to deploying and actually getting machine learning products out there?
the talk that I'll be giving in the Apply meetup, it's gonna. I don't want to give everything away, but it's gonna talk a little bit about this concept of malleability that I think is pretty important for systems. And the idea is pretty simple, that like you want systems that are pliable, that are easy to kind of manipulate in some sense. And so at least for this talk, I go through like 3 things that I think are important. Number one is measurement, being able to measure things inside the system and understand what's actually going on. Number 2 is monitoring, which is taking this measurement piece and basically stretching it over time and trying to track how the system is changing, how its behavior evolves over time. And then 3 is maintenance. So you can't really fix things until you can measure properly, right? Like I can't tell you how to fix a problem unless I can actually measure and find out that a problem exists, which is why the first 2 things are so important. And then maintenance is really about taking this information and then taking actions inside the system to improve it in some way. So maybe a model's degraded over time because there's been distribution shift or concept drift or something. And then maybe the solution to that is an intervention that adds more data to your model in some place so that the model improves and is kind of fine-tuned or retrained in some sense. So these three pieces, I think, are all kind of independent, interesting aspects of this general notion of malleability for machine learning systems. And that's something that I think is conceptually how I think about it.
Really interesting there for me is that you want to have systems that are easy to manipulate. So with these three different pieces, is that what you're talking about? If you have these three pieces, it will be easier to manipulate.
Certainly, I think these three are kind of functionally things that you would want for saying that a system is easy to manipulate. And then on top of this, there's this additional kind of I would say the cherry on top, which is interactivity, which is you can do these things in like the concept of measurement, right? Like it's just a functional thing, like you can measure the system. It doesn't really tell you how you can measure it, right? Like there might be things that you can actually measure in terms of like, let's say metrics to be very concrete. But how do you build the interface so that different stakeholders can do that measurement in different ways that they require? So for example, an ML engineer is going to need to measure maybe metrics over different slices of data that they care about and so on. And that's going to be different than, let's say, a regulator that wants to measure if this machine learning system is doing the right thing and is actually not biased or discriminatory in some way. And so you're going to have different stakeholders that need different interfaces and different kind of desiderata to interact with these functionalities like measurement, monitoring, maintenance. And that's where there's this work to do with interactivity and going in and kind of building out what the workflows look like and thinking through kind of what is the right way to build them. And that's the fun part, I would say. So it's like kind of this like foundations of like functions that you want, plus this little sweet sauce on top of like interactivity, which will make it interesting.
So then if I'm hearing that correctly, it's that each person is going to be able to build their own style and choose their own flavors.
Right, exactly. And part of the work of, I think, academia is figuring out what the right way to do that is. What is the right way to actually build in these capabilities so that it's easiest or like most, it's least misleading in some cases, right? Like, for example, measurement is a pretty difficult problem because you're trying to kind of divine what the system knows, or at least where you anticipate it might fail. And so, it's kind of fraught with potholes on the way, because you could, mislead yourself in many situations by thinking that, maybe you slice your data, you filter it, and you see some slice has low performance, but actually you didn't have enough samples. So you're making kind of a misjudgment about whether the model is bad on that slice or not. So things like that, where you really need to design good, like HCI, you need to have good statistical techniques to actually, estimate things correctly and so on. So all of that is going to be important in conjunction to kind of bring this together. And that's where, the academia piece comes in, which is really kind of spending time thinking about these problems.
All right. So talk to me for a minute about the Robustness gym project. Yeah.
So I think one of the things that we realized, me and my advisor and kind of collaborators at Salesforce Research, I think maybe now it's been like 8 or 9 months, that it's starting to become clear that models are kind of commoditized now, right? Like it's pretty easy to build a new model or to take existing models off the shelf and repurpose them for whatever it is that you want to do. So you can go to Hugging Face and grab a model and then start playing with it almost immediately. And what is getting clear is that what people worry a lot about, at least from conversations we had in industry, was that how do we get these models to do what we want and kind of get that last mile out, where like the model's doing the right thing on average, but it's not quite doing what we want on these like particular slices of data. Like it's not performing at parity for things that we care about. And so that's what really motivated this interest in evaluation, because it was kind of clear that we don't have enough fine-grained tools to measure what's going on yet. And in the experience of companies, they actually go in and build these dashboards for their systems and models to figure out what's going on, right? Like they are not necessarily satisfied with like observing an average accuracy score. They want to know what's actually going on underneath the covers for different, slices of data, and they want to track that. So it became clear that like it's good to think about this problem systematically and start investing in it, because this is going to be the kind of bottleneck for future machine learning systems where the next set of improvements are going to be on these finer grained things. They're not going to be like 20-point jumps on ImageNet anymore, because we've kind of maxed that out a little bit. So we need to think about like robustness and these problems in like building robust models a little bit more carefully. And evaluation is kind of this big bottleneck there. That's what motivated kind of building out this toolkit, Robustness Gym, which is a general Python toolkit that helps you kind of build out a different machine learning model evaluations and then visualize them pretty easily. So it's kind of you can think of it as a loose workflow that helps you organize your evaluation and then put it together in kind of a nice way, visualize it easily, and kind of iterate against your evaluations. And we support a lot of different kinds of evaluations. We started out, with NLP as the main focus. And we've kind of been slowly branching into other areas of machine learning. And we have some kind of more exciting stuff coming up there with more support for different modalities and so on. That's still in the works.
This is really interesting to me because I was just talking to somebody last week about the new EU regulation. And in that, they spoke about how the machine learning models need to be robust, the data needs to be robust, and it needs to be, I can't remember the other word that they were using, but it was something like, it needs to be complete. And this to me feels like a nice way of testing that. Of course, it is a little ridiculous in the EU regulation where they talk about that, because we both know that you can't have full robustness. Like it says, you need to be robust, but what does that mean? We can't guarantee full robustness ever. Have you seen that regulation? Have you thought about that and how this plays into that at all?
I've been working a little bit with folks in law and policy at Stanford in kind of laying the groundwork for a potential, application of Robustness Gym and algorithmic accountability, which is, kind of some of the stuff that both the EU and also, a lot of organizations in the US that worry about this area, they talk a lot about. In that kind of way, like the question is like, how do you run these impact assessments, right? How do you understand what the algorithm is doing, who it's impacting, and what its behavior is? And I do think that tools like Robustness Gym and even other tools can be applied to this to make it more computational, because I think the things that I've seen are that the bottlenecks right now are that there aren't enough computational tools to actually make this possible. Like this process of doing these assessments of machine learning systems that are deployed and used by people, it's so far just at the stage where it's mostly law and policy people telling you what is important or not and what they would like to see, but it's not enough machine learning engineering people building the tools that will make that happen. So that's where the crossover I think can happen, and it's a very interesting, rich area pretty early. And we're still thinking about what to do there, but I think I've had kind of good early conversations with a couple of folks at Stanford, and we've assembled a team, so we'll see where that goes.
I'm super excited for your talk at Apply. I think there is going to be so many gems. You just gave us a taste today, but I'm already like wanting more and wish it could be tomorrow. I know that you are doing all kinds of other great stuff. If anyone wanted to continue the conversation with you, what's the best way to get in touch?
Yeah, Twitter is always great. I'm at KRANDIASH on Twitter. And the other thing is a shout out to a seminar series that we run. I host a seminar series every week on Thursdays. We post it on YouTube, it's live streamed. But if you're interested in machine learning systems, we invite a lot of speakers from industry, academia, startups to talk about technical challenges and kind of interesting systems that they're building. This is the
ML systems seminar.
Yeah, this is the Stanford MLOps seminar series. The a very wordy name, but yeah.
But it's legendary. I knew about it even though you didn't say the name. So
Yes.
anyone who
No.
actually, is involved in this, they probably know about it. We'll leave all the links in the description.
Thank you so much. Yeah.
Yeah, and this has been great, man. I'm excited for your talk, and I'm excited to chat more with you. We will see you and everyone else on the day of the Apply event. Take care.
Awesome. Thank you so much for chatting, and yeah, really appreciate this conversation. I always enjoy talking about my work, and you ask great questions. So
Excellent.
And you have a great mic, so
That helps.
Yeah, that helps a lot.
Yeah.